Section 2.1 is titled Solving Equations by Adding or Subtracting. Two vocabulary terms I'd like you to learn. An equation is a mathematical statement that two expressions are equal, and the solution of an equation is a value of the variable that makes the equation true. There are two properties. The first property is the addition property of equality. What this states is that you can add the same number to both sides of an equation, and the statement will still be true. So if we have a equal to b, and we add c to both sides, the left side still equals the right side. And in our example, we have that 3 equals 3, adding 2 to the left and the right, and we have a true statement that 5 equals 5. Similarly, we have the subtraction property of equality, which states you can subtract the same number from both sides of an equation, and this statement will still be true. So again, we have a equal to b. If we subtract c from both sides, we'll still have a true statement. And in the example shows that 7 equals 7, subtracting 5 from both sides, and we end up with 2 equals 2. Both of those properties you probably just have learned that you need to keep equations balanced, so whatever you do to the left, you need to do to the right. So let's solve the equation and check our solution. On number 1, we're solving for a. We have 5 being added to a. So in order to solve this equation, we need to subtract 5 from the left and from the right. Subtracting 5 from both sides will give us a equals -1. And then we then need to check our solution. When you check your solution, and I'll ask you to do this in the notes, you need to plug your answer back into the original problem. So if we plug -1 in for a, it was -1 plus 5 equals 4, and we're checking that the left side does in fact equal the right side. -1 plus 5 is 4. Remember your rules for adding numbers with opposite signs. You actually subtract them, and then your answer takes the larger number's sign. So this in fact is true, so we know that our answer is correct. On number 2, we have -10.7 equals 6.2 plus m. Over on the right hand side, we need to get m by itself, so we are going to subtract 6.2. Remember, you always do the opposite. Subtract 6.2 from both sides. On the right hand side, we're just left with m. And on the left hand side, we have a -10.7 and a -6.2. You could think of it as -10.7 minus 6.2 or -10.7 plus a -6.2. In either case, we need to add those numbers, so 10.7 plus 6.2, and they're negative, so our answer is going to be a -16.9. We do need to plug our answer back in to make sure that it works. So we rewrite the equation, substituting our answer in for m. So we have -10.7 on the left, and on the right we have 6.2 plus a -16.9. Those numbers have opposite signs, so we actually want to subtract 16.9 minus 6.2. We get 10.7, but since the 16.9 is larger, it has a negative sign. Our answer, or that also needs to be negative, so this is correct. We know that m equals -16.9 because when we plugged it back in, the left side equaled the right side. Again, solve the equation and check your solution. On number 3, we have -20 equals -38 plus b. If you'd like to try this one on your own, go ahead and press pause and then check your answer. Here we have a -38. Remember, you always want to do the opposite to move something to the other side. So we actually want to add 38 to both sides. On the right we get b, and on the left we have -20 plus 38. Those numbers have opposite signs, so we actually want to subtract 38 minus 20 gives us 18. 38 is larger than 20, so our answer will stay positive. So now we need to check our solution. If we have -20 equal to -38 plus 18, because that's what we said b was, do we get the same thing on the left and the right?
Negative 38 plus 18, again, those numbers have opposite signs, so you need to subtract them.
38 minus 18 is in fact 20. And since 38 is larger than 18, the 38 has the negative, so our answer is negative. So the left does equal the right. Hopefully you got that one right, and if not, you can see where you went wrong. On number 4, we have 5 over 2 plus x equals 1 over 2. We'll deal with some shortcuts with fractions later, but right now, all we need to know is that both of those denominators are 2's, so we'll be able to easily add and subtract. We need to get x by itself by subtracting 5 over 2 to the other side. On the left, we get x, and on the right, we have 1/2 minus 5/2. Or you may think of it as 1/2 plus a negative 5/2. Those answers have opposite signs, so we actually need to subtract. 5 minus 1 is 4. We use our common denominator of 2, so we get x equals 4 over 2. But since 5 over 2 is bigger than 1/2, it's negative, and now we can reduce this down to negative 2. If we were to plug it back in to check our answer, 5 over 2 plus a negative 4 over 2 equals 1/2. This is saying 5/2 plus a negative 4/2, so we're actually subtracting. We get 1/2 equals 1/2. So we know that our answer of negative 2 is correct. I would like to point out in your homework, I do not require you to check your solution. I do require you to show work. But checking your solution is always something you can do when you're solving equations, so there's really no excuse to getting an answer wrong. So let's just do a few more examples. Solve the equation. A minus 5 equals 7. We know we need to add 5 to the other side. And we get that A equals 12. Go ahead and try this next one on your own, see if you get the right answer. We want to add 9.3 to the other side. Negative 4.1 plus 9.3. You actually subtract those two numbers. We get 5.2, and our answer will be positive since 9.3 is bigger than 4.1. Remember, that goes back to your rules for adding and subtracting. A few more examples here. Add 25 to both sides. So we have a negative 53 plus 25. You actually want to subtract those two numbers since they have opposite signs. We get 28, but we want to make it negative since 53 is bigger than 25. And on number 8, we're going to add 3 to both sides. And we get n equals negative 5. Since the signs are opposite on the two numbers, we want to subtract them and give our answer the sign of the larger number. Let's take a look at a word problem, and then we'll be finished with the lesson. After spending $45.90 at the mall, Leah has $23.50 remaining. Write and solve an equation to find the amount Leah had before she went shopping. So we know how much she spends, and we know how much she has remaining. We need to know how much she started with. So you actually could set up a couple of different ways here. If we don't know the start amount, let's call it X. We know when we go shopping, we need to subtract that amount from what we originally had, and we'll be left with what's remaining. This is one equation that you could have written, and then we'll solve it to get our answer. So we want to add 45.90 to both sides. So we get X equals 23.50 plus 45.90, $69.40. Now think for a minute if there's another way maybe you could have solved that. We could have used addition in our original equation. We could have said X was equal to 45.90, the amount she spent, plus 23.50, the amount she has remaining. which is actually what we've done right here. This is an addition problem. So our answer is she had $69.40 before she went shopping. In class, we'll work on worksheet 2-1, and that ends the lesson.